Hello everyone, let's wait a little bit until others join us and then we'll start. Okay, let's start. Hello everyone, welcome to our today's session. Hopefully the holiday was great for everyone. And so now we are back. We'll have a session today and on Friday. And according to our planner, we have the session on Saturday next week. And so this week we have 2 sessions, and next week it means that we have 4 sessions as it's planned. So the plan for today and for Friday as well. Today we will before today. So until today you had to complete activity 05. So that was according to the plan. And so the upcoming activity is extra 04, and then it is extra 05 and activity 06 after that. Today we will talk about activity 05. I checked. I hope everyone's who submitted this activity. Everything was fine for them. So let's those who couldn't manage to complete it, let's complete it together. So let's go to the Yes. Before we move to Tutorial 5, today we'll also start talking about Java collections, about some key features of them, and the main point I would like to figure out with you is performance test, because basically when we use the collections, especially if we work with big data, with so many relations, the keys and the values, different values. In this case, the key point for us is what type of collection do we use. Not only collection in Java, but also again in other programming languages. There are the table types you may use, basically at data types, and not only table types, but in general the data types you use. Basically, it may affect the the performance of your program, how fast or how slow your program works. So that's why it's really important to understand which data type better to use for one or another case, not only in Java but in programming in general. So we will have testing. So it means that we'll also have the timing. So the stopwatch will be, like we'll see how much time one or another collection type it takes to process the data. So we will test it together. But yeah, first of all, let's start with activity 05. So it was related to encapsulations, and so maybe it's better we can just simply go through them to do basically what we had to do. So first of all, you had to create the class water-road as a subclass of class road, which comes from activity 04. So in this case we use the class from another package. So that would be water-road. And here we can mention that this is the subclass of the class road. So in this case we can import a package. So it means that all the classes from this package will be visible inside this class, or we can do it just directly this way without importing the class. It means that it will just, in this particular case, it will see this class and no other classes will be available from activity 04 package. So yeah, this is the first step. You create a subclass, and yeah, so basically you can also do it using the using Java Wizard, Eclipse Wizard, but you can just simply write it inside the code. There's no difference here. So yeah, now we have the class, and we also need to create the constructors. So first of all, you can generate the constructor from here, but I prefer just directly write it this way. There's no difference how you do it. It depends on your habits and how it's better for you to do. Yeah. We start with the error because sorry, that's the wrong class. We don't need to touch this class. Sorry. Sure. Okay, so now we need to please remember that we need to call the constructor of the superclass. In this case, so since we don't have the error, that's because in the superclass road, we have the constructor without any parameters, this one. So in this case, this constructor will be called automatically. But in our case, we need to create the constructor with the parameters. So at the moment I will change the font, because it seems that unfortunately I cannot resize my screen right now, so I will quickly change the font size. So that's actually I know there are some shortcuts. The shortcuts. Okay, Control plus, Control minus. Yeah. So I need to. So just the information Control plus and Control minus will change the size of the font here. Okay, now I think that should be better. So let's call the constructor from the superclass, and so we call the parameterized constructor. It should be from to and this type. So this is the constructor, and another constructor also should be empty constructor. So that's water road. We also need to call the constructor from the super, but yeah, in this case that's basically we can actually skip it, because this means the same as this means. It means that if you do not provide my fault. This means the same as this means. Of course, we need to define a constructor, otherwise the program will not allow you to create the instance of the class, because it will see this constructor as the only constructor. But we need to have a parameterized constructor. But so in this case we can, but it doesn't matter, just to make it more ceremonial, we can add this super call here, but it will be called anyway. So we defined all the constructors needed, and the last thing is to override to string method, which returns string in form water road, then a long dash, and 2, and number of kilometers. So let's do it. Let's override method to string. Right here we'll return the class name, that's the same name of the class. Of course, then we the idea here is that, please remember that this is from -2 can be taken from the superclass, from the class road, because please remember that right here we already have this logic. So basically what do we need? The simple way, we need to extend the logic from the superclass. So in this case we can call super to string. So basically what happens, we will have the same string as we have in the superclass, plus we have the additional text at the start. Right, so this is what we need to do here, and this is basically it, what we need to do for the class water road. Then we need to create the class ship. Let's do it, it should be a subclass of transport. So let's extend the class transport. Again, we can do it this way. Just maybe to not confuse you, we can do it directly this way. Since basically the question for you may be when we need to import, when we don't need to import. If we just use once, then it's fine to simply declare it this way. But if you do it several times, if you not do it, but if you use this class several times, then it's better to import it at the beginning, just to not write all this long string every time. That's just the only reason to skip all these long namings and just import everything from GTM activity 04 and then simply use all the classes from there without providing the namespace here. So yeah, we need to create a class and also need to do here to store protected byte number of sales for ship. Okay, so we need to declare it. I think we can use. It's not mentioned if we need to use private or protected or public here. Let me check. Protected. Yeah. Sorry, I not noticed. Yeah, that should be protected. So let's do it then. Not needed at this point. So that should be protected. Right. So please remember the protected attributes are the attributes which are visible for the class. It's inside the class itself, plus also the attribute will be inherited. The definition of the attribute will be inherited to the subclasses as well. And also, yeah, there's some say crazy, but additional things a lot, like you can access from the same package and so on, but the key thing is inside the class you can access it, and also in the subclasses. So we defined number of sales. Then need to create the constructor. Basically, I can copy paste it from here. So that's this one, and of course, let's create public. Again, please remember, if you create protected or private constructor, it means that the class will be the instance of the class can be created the same way as we can access the attribute. So if it's private, then the class can be created only inside the class. The instance of the class can be created inside this class. If it's protected constructor, then inside the class and in the subclasses of this class, and so on. It's not and so on, but there's default and also public definition access modifiers, but yeah, this pretty much makes sense. Okay, so this is the constructor. Yeah. So and need to define of course, need to call the superclass. Yeah. In this case, we have the error you can see, and the error is that we need to call the constructor of the superclass. Again, the idea is for the superclass is transport, and transport class does not have any unparameterized constructors. That's why we must create the call to the constructor of the superclass. That's why we need to provide the attributes here. So we can check what's the constructor here is. That's ID, consumption, and chunk size. By default, we can just provide that that's 0000. That is done here. No errors anymore. And also need to, for sales, so since this is additional attribute, we also need to provide it here. And basically here we can see the idea of how most subclasses are used. We just have all the same parameters taken from the superclass, and we add something more, which is protected by sales in this case. Right, so this is done, and then you need to override method move to return string. Therefore, ID ship is sailing on route with X sales. So basically, Oh yeah, so here's the note that fuel is not used when shipping is not because it uses wind for sale. Yeah, that's for sure. And yeah, here's the important thing: we need to return cannot say on the road. Yeah, if it's not water road. So in this case, we need to check if the road passed to the method move is water road. So first we need to override move. Oh, sorry. Because I was just located inside method. So yeah, now we override it to method move, and as it stands in the description, we need to check firstly if road is instance of water road. There's two brackets here because there will be only one. So as it stands from here, the text should be ID, then ship is sailing on. So this is ID and ship. ID and ship. One moment. Yeah, so we have super class, and yeah, here we had the basically this string comes from here. So as you remember, we have ID, we have the class name, and this is basically what is written here. ID ship. Now, please remember, even if we call the method from the super class, like that in this case. So this is this get tag, and then is sailing on, then just the road as string, and with how many sails do we have? Just to be more precise, let's use this this X and we provide the sails. Right, so this is what we have here. Okay, that should be fine. And yeah, so please remember that since we have the method getType called from the class ship, it means that the instance right here, basically the name of the class we're currently in, is not transport like it is mentioned here, but this will be ship. So this is a really important thing to understand about the inheritance and polymorphism, because in real life, when you work with different classes, different frameworks, you'll see this is Java or any let's say any object-oriented programming language. Then you have again classes, the interfaces, the superclasses, the subclasses, and for such cases that you can see here, you have the you may face something like this, like you have the class transport, right? So you are inside the class transport, then you have the method, and you see here, okay, there's ID, okay, that's makes sense. It is defined inside this class, so everything is fine. And then you have this thing, and so right here you just read, okay, this so this will return the name of the class, and you may assume that since I'm in class transport and I call the method this get simple name, so in theory, and just you may think at first sight that this will return you the name transport, but in fact no, that's not true. In fact, that's not always true, because you may have a subclass, and when this method is called from the subclass, then this will return the name of the subclass, not the name of the class it is defined in. So this basically shows the original name of the class, and this is what the inheritance is about. You may see lots of such cases in real life, and this may be confusing, like in this case, but nothing to do. This is how it works, and maybe the key thing here is that it's better to use a little bit different thinking here. So just to not always be sure that such a thing may return directly what is written inside. You should also think that the class may be inherited, and then the result may be different, and the same as you can see here. So this is what I call here, and this is the case when road is instance of water road. So remember that instance of returns true or false when the object provided on the left side is the class belongs to the class or the subclass of the class, or any subclass of the class water road, or the interface. It can also be the interface or the abstract class. Then it's true. Otherwise, that's false. This is needed to actually check if basically directly checks if road is water road. And just like this, and please note that in the case when this is false, we need to return that we cannot sail on the road. And this is it for this class, nothing more. Then we have two more classes here. First is vehicle class, so then let's create it. Vehicle class, and it should also extend the class transport. So again, extends transport. Just in this case, we can maybe not confuse. We can do it this way. And also in addition, you need to define a new attribute, protected integer number of fields. So that would be protected integer fields. In fact, you can also define it this way. The integer, that's the proper class of integer, also works the same way. In this case, in such simple cases. But maybe let's use integer as we usually do in such cases. Then I need to implement the constructor. So then I will copy paste to here. And again, I need to call the constructor from the superclass. So again, what we have ID, we have consumption, and we have the size of the tank. Right? So we have it here. And again, another additional parameter. In this case, that's reuse. Right, so now we define the constructor. This is done. Then we need to redefine the method override. Redefine. These are synonyms. Basically, method redefinition and method overriding. These are the same terms. So I need to override method move and return the string in form ID. Vehicle is driving on road. And also the same as for water road. Need to check that that the type of the road is if it's just not road, then that's correct. Okay, that's a little bit. In this case, you can see the tricky point is that the road cannot be bottom road. In this case, we should know that road is directly the class of the object here. So let's redefine, and then we will see this thing. So we have the road, and then we need to check what's the class of the road, and in this case we cannot use instance of road because water road is also the instance of road, but this is not acceptable. We must sure that the road has the exact type, which is road, and in this case we cannot we're not allowed to use instance of, and in this case we can just compare the classes this way. Basically, for each class, the definition of the class is also the object. Right here you can get the object, and then you can get the class. This is the object class, and this is also the object. So basically, we need to compare if road get class and if class of the road is the same as the class of road. So in this case, we go to road class, and then we compare these two objects. So that's one thing. In addition, we need to check if the vehicle has enough fuel. That should also be if it can actually move on the road. So in this case, we can we need to check basically what we have inside the super class. Let's quickly check it. We have transport, we have the method move. So as you remember, here we can check if the transport can or cannot move on the road because of the fuel tank size. And in this case basically we can adjust. There are two options for us. The more precise option, I think, would be if we adjust this class a little bit, and then we will continue with our class. Basically, here we just need to check if we can or can't move. So in this case, I can create a private method and say it can move. At private boolean, of course. And this will return true or false if the transport can or can't move. Excuse me. So here we can provide roads again as well. So, and here let's basically can copy paste this logic and copy paste this logic. So if there's enough here, then we return true, otherwise we return false. So basically this is a small check. Sorry, that will be public because we'll use it, or that can also be protected. So we'll use in the subclass, and that's why it cannot be private. This should be protected or public. So in this case, can this way, that's one thing. And a moment, oh yeah, that's, oh sorry, that's the opposite way first. If unit is greater than the equivalent time, then we return false, and otherwise we return true. So then if we can't move, so if this returns false, then we cannot move. Otherwise we can move. So basically in this case I can check if this can move. Okay, so since this is the subclass, I can use the same method. So if this can move, then then I can just simply call the method this oh no, so I cannot yeah, so that will be the type, because we need to get the type as it stands here. ID vehicles driving on the road with so many vehicles here. We cannot reuse the method from the superclass because it's just saying that it's moving, but we actually want to have the text that we are driving. So that we just get that and we say that it's driving on the road with this much wheels. Okay, so that's if we can move. Otherwise can't move, then we return that basically one moment. Basically in this case we'll return this text. No, sorry, not this text, but this text. So in this case I can just simply reuse the method from the superclass. This will just return, maybe let me write a comment here, since to that the object road belongs to the class road, not just any subclass, maybe not saying, but need to exclude all the subclasses. This not possible to use instance of operator because it also includes the subclasses in check. So in this case we need to be careful and not use instance of in such cases. Alright, so this is this case, and basically what do we have right here? And so here we can just simply say that if the class is not rolled, then we say that we are not allowed to move on this. We have only water road, but in fact that there may be more classes which are instance of which are the subclasses of the class road. Then I say I cannot drive on the road. So this is it for this class, and then we have the last class, which is amphibian. So that's the class which is the subclass of transport. Oh yeah, regarding this thing, it's mentioned this is the subclass of transport, but in fact it's better to define it as a subclass of vehicle, but okay, maybe let's do it in the way as it is described. Basically there are two options, but maybe let's do it as it is described here. It should be the subclass of transport. Subclass of transport, and just then use this one. So then make content properties of amphibian private. So moment. Yeah, oh, okay, we also need to basically I need to define sales here. Private byte sales. Here, this then also need to define the constructor as well. Consumption, and type science. Yeah, basically here we need to use both vehicle and ship. But again, since we do not have the option to inherit both classes, then we can just simply do it the way that we just extend none of them and define all these things here. So basically maybe that would be faster if I just add the attributes directly from these classes. Okay, for ships we already added, and then for the vehicle, okay, we have wheels. In this case, wheels should be private as well. And it stands from the task, and I think we can. Okay, maybe let's just define all of them. All the attributes directly from here. Okay. That should be for consumption as well. Integer tank size, byte sales, and integer wheels. So we need to call this superclass, that will be ID consumption of tank size, and in addition also need to fill the private, all these attributes we have here. These are sales and wheels. Alright, so this is done, and So then I need to override method road. That amphibia behaves like vehicle on the ground and like a ship on the water. Yeah, this is quite interesting thing. In this case, we can do it. Say in a little bit interesting way. Yeah, in this case, the problem is that again we have the problem of multiple inheritance. But okay, that's not a huge problem for us, because basically what we can do, first we're going to need to override the method move, and moments. And yeah, here we need to check what's the type of the road. So again, if we are on the water, so that will be water road. Then we need to cast. Actually, yeah, we don't need to cast here. So if that's the water road, then we need to get type, and again is sailing on, and yeah, in this case there is another solution. And let me think. Yeah, okay, I think it's better if we use another solution. This will not be the most clear solution, but this will not require us to rewrite the same logic. Okay, I'll do it in this way. So that's as it stands here, it should behave like a vehicle on the ground and like a ship on the water road. So firstly I will define the class transport. Okay, basically in this case, since I need to use it twice, I can just import and to not write the wrong name. So I define the transport variable here, and then what I can do, I can basically pass transport water road transport, sorry, not water road. I need to create one, so that's for sure. I need to create so that's the ship, because we are on the water. So this is done. Else, maybe let's do it this way. Else transport is the one moment. Yeah, that should be transport. Not transport, but vehicle. Vehicle, and here we can again pass ID, consumption, tank size, and use. Right, so now we have the instance for transport. Basically we can use else, but we better use else if, just to be sure that the road is the instance for the vehicle, it should be road. So in this case, we again need to check if Maybe let's just use else. In this case, it's not so important. It should not be important if we use else or else if, because the vehicle class will basically check it. So the check will be done in the vehicle class. And once it is done, then we can just basically do it this way. Transport and encode the method conversion we passed well. Yeah. So now this is done. Maybe some mistakes. May be here. So let's check if we haven't missed anything. Maybe something is missed, but if it is missed, we will see. Okay, something is missed. Let's see what is missed. Okay, that's the issue with the transport. When we call the method, so that's a moment. Yeah, it says that the integer value is not correct. That's interesting. So let's go to the call, to the transport. Oh, one moment. Maybe let's quickly check if the transport method is correct. The transport class is correct. Oh, okay, so yeah, here we had the issue, result compilation problem. If you need it cannot be, oh sorry, that's interesting. If you need it, okay, here we have the error. Okay, it's my fault, sorry. Okay, so now we got rid from this error. Yeah, because the variable was not visible. So let's quickly check again, just to be sure, because the activity of 5 depends on activity of 4. Yeah, okay, activity of 4 is fine. So now let's quickly check if everything is fine with what is but what is wrong with activity of 5. Okay, still there's the issue with the transport. Okay, vehicle fuel consumption error expected. Okay, and okay, I need to say that amphibia is driving on Riga. Okay, so we have the error here, and this is, I think, this is related to the fuel, but yeah, in this case that's interesting. That's interesting. Why it checks the transport? Okay, it seems there's the issue with consumption. Let's quickly check if everything is correct here. Yeah, so here I passed to the silver and it's interesting why it shows the error on the consumption. And consumption error expected. Okay, maybe I got the issue. It's maybe related to this method. So okay, yeah, I got, I think. Yeah. So I forgot to reduce the field count size first. That's my issue. Yeah, so here we check if this can move or not. But I forgot to reduce the field size. Of course, that's my issue. Not this field size, but moment. Sorry. So that would be this. Yeah, we need to use setter because this is sprout attribute. Let's refill intank. Then we can, yeah, actually, this will be. In this case, we will need to calculate it, so that would be fill in tank, and yeah, so this will be equal to the get fuel in tank minus fuel in unit. Yeah. Okay, and fuel needed, that comes also from them. From this class. Yeah, okay, maybe this is not the most optimized logic, but yeah, sometimes it will take a little bit it was also the consumption. Okay, I think we can get consumption. Okay, so what's the issue here? Okay, cannot convert from float to integer. Oh yeah, that should be float. Okay, that's done as well, and then we can set fuel in tank. This one, right? So this is done. Let's see, what do we have here? Okay, everything is done except okay, and this is what I also expected. That's the text related to the amphibian movement. Yeah, I need to say that amphibia is moving. It's moving, not vehicle. Okay. Oh yeah, this is quite tricky, I think. So in this case, yeah, the problem is that we actually then need to copy paste this method here, which is not so good. Because sorry, not transport, but this vehicle class. Basically, this is why I said it's better maybe to in this case that would be better if we define vehicle as the superclass of the class amphibia, not the transport, because we just need to copy paste this method. I don't really like to do it, but yeah, in fact there's nothing to do here. That's why I need to yeah, that's not the best thing here. I don't really like it, but actually, yeah, there's nothing to do, in fact. Okay, yeah, and in this case we should also It's really basically the idea is that we just need to copy paste these two methods and reuse them in the class. In the class amphibia, of course, we can do it. That's not the problem for us, but this will not look pretty much fine from the coherence of the logic point of view. I think there's again the best idea would be to just define the superclass be equal here, or okay, there's really nothing much to do here, so it's not so good. But okay, let's maybe let's then copy paste. I prefer this way, but seems that this way will not work for this case. Okay, then I'll just comment it out and then just write this code again. Okay, and maybe let's check whether we can copy paste this logic then. Everything is fine from here, and here we just basically can check if the road is the road class else. In this case we use else, and under else we will we'll define the logic for the vehicle. Sorry, not for the vehicle, but for a ship. For the ship, and let's just say that this is this case. Okay. So let's check now. So everything's fine now, but again you can see that the ugly point here is that I just had to copy paste the logic. That's not, but again the best solution would be if you just assign the class vehicle. In this case this logic will be used. Basically the only problem is get type method. So previously what I did here, I just not here but here I just defined the new variable, and then I just based on the variable I called the right move method. But the problem is that move method uses this get type, and get type comes from the object, so it means that the type here will be vehicle and ship. Sorry, not and but or ship, based on what we have here. So in this case that will be type ship, type of transport. In this case the type of transport will be vehicle, but we actually need it to be amphibia, and that's why this option did not work. But that's quite interesting, food for thought. Okay, so now we finished with this activity, and after the break we will move to the collections. Okay. Okay, let's move on. So now we move with the collections. Java collections. You already know. We already used, of course, different collection types. Mostly, these are array lists, maps, tree map, a hash map, and also sets, tree set, or hash set. We also used the linked list a little bit. So today we'll just go through them again, and again take a look on the key things about them. So basically, again, the structure of what is the structure of the collections in Java? First of all, we need to think about, basically this is collection itself, it's the interface, and we have lots of different sub-interfaces and classes which actually implement this interface. The most popular are map, lists, maps, lists, sets, and queues. So basically, implementation is mostly related to array, hash, or link. So we have basically the prefix for for the collection types. Then we have our favorite iterator. We already used a lot of times, not only for the collections, but also for different other different structures. And also we talk about sorting and ordering. We'll see how to compare. Then, because again, there's really important to think about the comparison. Of course, we know how to compare the numbers, if it's integer, float, or whatever it is. That's also it's also quite simple how we compare strings, for example. We know that we can just simply go in an alphabetical order and compare two strings. That also pretty much makes sense. But if we have like more complicated structure, like let's say if it's the person, for example, if we want to sort persons and some order, then we cannot just directly define the way how we can sort such class, and that's why we need to define our own logic to sort. But basically we start with collection interface. Collection itself, that's an object that groups multiple elements into a single unit. Basically, that's again not only in Java, but in lots of programming languages there is such feature which is mostly related to object-oriented. I think because the arrays and our arrays also are the objects. In Java, in other languages it works a little bit differently, because basically the arrays themselves are considered as not the primitive type, but sometimes arrays are also considered as primitive types in other languages, but the idea is that they mostly belong to such types of data types like integers, characters, also strings. Again, in other languages the representation of string may be more simple than in Java, but again, it depends on the language. In other languages there's such possibility that the elements can be stored in the arrays. In Java, again, we know that we have the arrays in Java, but the idea is that the number of elements in one exact Java array object is limited. Yeah, and that's why we cannot just simply mutate this number in one another case, in one another way. It's always fixed. That's why to store the elements, to work with the elements, we need to think about a more complicated way, and this is basically this way can be one of the ways how we can implement it is using the collections. Of course, we already talked about the XML files, and as you remember, we have the nodes for XML files. It means that you have, say, one element of XML, and then you have the sub elements which are considered as the nodes. So in this case, we can also say that this is the kind of collection. To be honest, I don't remember if nodes classes implements collection interface. I think that no. Just need to not lie to you. I think that no, but the idea is quite similar. We have the object which stores the set set of the elements. And usually it should be the set of the elements with one exact type. Since we're talking about object-oriented programming, then the set may also include the subclasses of the classes defined. Also for Java collections, it is not possible to store primitive types, only the reference types. And if you want to use primitive types like integer, char, you can just simply use the corresponding proper classes, integer, not char, but integer and character, and this will solve your problem. So regarding collection interface, there are most prominent sub-interfaces like list, which is an ordered collection, sometimes called sequence, and also there's such type like vector, or we will not use it, but it's also the list, and it's thread safe list. Basically, when you work with multiple threads, then vector, the option to use vector is considered as a pretty right choice. But in our case, we don't work with multi-threading. That's why maybe we will not use this option. Then there's the set. That's the collection that cannot contain duplicate elements. That's also choice queue. That's the queue. That's the collection used to hold multiple elements prior to processing. Basically, in this case, for the queues, the idea is pretty much the same when we talk about simple queues in real life. Like if that's the queue, today we have so many news about the queues to the stores, which are now open finally. Basically, so it means that the first who goes to the store, the first who is in queue, this is the first person who goes to this, who comes into the store. The same is for basically the idea for the queues is also not the same, because again the types of queues may be different, but the idea is that we for the queues we queue collections, we want to implement such a thing that some elements go in, some go out, and based on the type of the queue, it depends on the type, which element and how it goes in and goes out, what's the order of them going in and going out. So it depends. For example, basically there are multiple examples from the programming perspective. Again, the most obvious example is stack, because we know that when the program is executed, we have the methods. Then one method calls another method, then another method calls one more method, and so on, and at the end you're finishing that you have the list of stacks, which basically represents from where the method is called. And so in this case, let's say that we can basically, from the programming point of view, when you execute the program, of course, this information is stored somewhere, right? Because the program should understand basically where to navigate. We do not program it, but we don't write it in our code. It is done internally by Java. But of course, this should be written somewhere, not by us, but by some generic things. And in this case, the stack is also represented as queue, because again, we have the first. Say we have the information. Imagine that we should have the collection, which actually stores the information about the stack we are currently using. And so the method stack we have. And so this collection should store all the stacks, means that all the methods from where, at which line we call the current method, and so on. In this case, this collection will store all these elements, and so here we have last in. We have such order of going out of the collection: last in, first out. So means that the last one who comes to the collection will be the first one to go out. So this is basically the idea of queues, and if such things are needed to be represented, then like stacks, it can be represented by queue, collection type. In fact, there are lots. So in my experience, to be honest, I have not really programmed the logic with queues by myself, but I actually work with the programs which use queues. And the idea, in my experience, there were lots of such cases, and basically the most cases are related to some schemas. Also the schemas may be quite representative way, because again, let's imagine you have the schema, the flow. Mostly that's the flow. Like you define the flow. Imagine you have some logic, some program, which should go in one or another way. Basically, you can define the path of the program by yourself. So that may be, for example, like you have the classes, the methods, and then you define the paths. Which class should call which? You do not program it, but you define the path. Which one should call which method? What are the values to be passed, and so on. And again, since in this case we have two sources. One is configured by programmers. That's the program, and another is configured by those who define this path. In this case, also queues are used to actually go through step by step in such schema. But that's maybe a little bit complicated. The idea is that if something is defined in the way that we have kind of the flow of actions to be done. In this case, also queue is quite popular. Alright, then we have the map, also very important thing, because it actually represents, in Java it represents the structure of table. And for the tables, we have the key fields, usually the key fields, and based on these key fields we can actually find the values, also stored in this table. And that's why map type is so popular, because it actually has the keys and it has the values. So it provides the mapping between the keys and values. And that's why it's so important. And then there can be sorted set and sorted map. So these are the set and map which allow sorting. Yeah. So this is how the API of collections look like. Again, what we have on the top. On top we have the interface collection. And then we have also 3 sub-interfaces of this interface: set, list, and queue. So these 3 are the top types which can be used. Four types. Also the map is here. So then we need to go to the classes, because actually let's find that we have the interfaces, but to be able to do something, we need to have the classes, right? And that's why what do we have? We have priority, which actually implements the interface queue, and then we also have linked list, which can actually, it actually implements queue and list interfaces both. So it means that linked list belongs to both structures. Because as you remember, linked list means that maybe talk deep, but maybe you can. Let's talk now. The idea of linked list is, from my point of view, is mostly related to queue, because all the lists, all the collections storage of all the collection types depends on how the stack is defined, and in different cases, in different interfaces, in different classes, this storage is defined differently. We know that for the array list, it is defined as the array. So it means that the list is just contains the array of the elements defined there. And every time we force to change the size of the list, what it actually does, it changes the size of the array. Not changes the size, it's just, sorry, that's absolutely wrong. It creates a new array. So basically every time it copies the array we have and it just moves it to the new array. And that's why it's called array list, because the values are stored inside the array, and using this interface, when we change the size of the collection, it actually creates a new array and transfers copies all the elements from the previous array. Comparing to the linked list, which has, from my point of view, quite interesting way of data storage. For the arrays, again, that's quite simple. We know how the arrays work. That's the pointer to the memory, and then we have fixed positions there, and all the elements are just stored one by one there. For the linked list, we have a fixed number of elements, and these elements are stored from 0 position to the actual number of the elements minus 1. So for arrays, that's quite good. Maybe that's better if I show you the picture. That would be more correct. I think this should be pretty much okay. Yeah, array just points to the elements we have inside the memory. just basically it points to the start usually, and then we just provide the position. It actually gets the information, or we can access the elements on the place in the memory on the corresponding position. This is what we have with the arrays. For the linked list, the structure is built in the way that again we have multiple elements. Please remember that all the elements in the collections all the collections can store only the elements defined as the reference type elements. So it means that these are the objects, and they have the references, right? So basically, all the elements of linked list are the objects, and basically the key point is how can we link these elements. And the idea is quite simple. So this is the ordered list. So we have the order first one, which like we pass, let's say, 5 elements to the collection of linked list. First, second, third, fourth, fifth, and then the order of them will be the same as we passed them. So nothing special here. And the way how they are linked with each other, that's why it's called linked list, is that the previous element stores the pointer to the next element. Right? So in this case, if we have, let's say, 5 elements, then the first element stores the reference of the second element, so it points to the next one. Then the second element stores the reference of the third element, and the third element stores the reference of the sixth element, or the fourth element, and fourth or the fifth, and then the fifth just stores nothing. So basically, this have some nice pictures, and this is how it looks like. So we have the head, then we have the first element, it stores the reference to the next element, and it stores the reference of the next element, and so on. So that's basically how we link them. Yeah, priority queue, and that's what I said, vector and array list, so these are mostly used type to represent the simple array. For array, mostly we prefer array list, but vectors can be used if we use multiple threading. And then we have the set. For the set of hash set, linked hash set, then the sorted set, which is basically, so these are the interfaces, and at the end we mostly use tree map. Please note that all the classes by default extend the class object. So let's start with map. As I said, the main representation for the map is the table, are the tables. For the map, it's simple. We just map keys to values. Okay. So nothing special here. It cannot contain duplicate keys, of course. Basically, I think nothing. There's no structure in this word which allow duplicate keys. Maybe there are some structures, but usually doesn't make sense, because the idea of key is that basically it works the same way as the function works. Because the definition of the function. The definition of the function in mathematics mostly. The definition of the function is that we can have the mapping for the argument of the function only one mapping element. So we have the function returns us the value, or it can return us nothing. It's not possible that you pass the you pass the argument to the function, and then it returns you two different values. The same for Java. Yeah, like if you call the method, it's not possible that the method for the same arguments, for all the same parameters, returns you different results. Yeah, that's not possible. You should always return the same result for the same attributes values passed. Otherwise, something is wrong with this method. Same is for the function. The same is for the mapping. So that's for sure. We pass the key, and based on the key, we can have the value, and we can also have no value, because so that will be the case when we pass the key, but there is no actually such element with this key. That's also possible. So for the collections, we have the interfaces which help us working with these collections, and for the map we have the methods put, which adds new element, get, which retrieves the element based on the key, remove, which helps us remove the element from the collection contains key, just to check if the key exists or not. Just returns true or false, because sometimes we just don't want to read the value. We want to just simply check if the element exists or not. Also quite popular case. Contains value, that's the same as contains key, but for the values. We can also check if the map contains the values, the size, to just check the size of the collection, and empty to just confirm if the collection is empty or not. Then there are also some bulk operations for more than one element. Also sometimes it's possible, for example, put all. It means that you can just put another collection to this collection, to the collection map. Clear, you just clear, remove all the elements from the collection. And also you can get the set of keys, set of entries, and also the set of values if needed. And mostly used types of maps is tree map and hash map. Then we have hash map, which allows one new element. We iterate through using iterator. It's fast, but not traceable. But regarding the fast, it's also quite interesting question. When we have the performance testing for the collections, we will see that it's not always the correct answer. That hash maps are fast. They are definitely fast for the large data. Like if we have so many elements, like thousands or millions, then hash map is quite fast option. For small data, hash structures are not the fastest. Okay, that's the outcome that we will discuss this and talk about the performance. Hash table also similar. It's also similar to hash map, but it's thread safe because it uses vector. Vectors also are thread safe in Java. And then we have the list. The idea of list is that this is the ordered collection, so it means that in the way you added the elements, in the same way the elements will be stored in your collection, and you can just simply access them the same order that they were created, they were added to the collection. We can also put duplicate elements. This is a lot because we do not have any keys. We do not have this instruction. We basically have the elements without any specific restrictions there. Yeah. So then for lists we also have the methods, how to manipulate with the elements. So these are get method. To get the element, we provide the position at which the element is located, and then we can get the element located at the corresponding position. Then we have set to actually set the element. And the position also, we can provide the position, and at this position we can set the element, the same as we work with the arrays. So basically we can use array list the same way as we use the arrays. We can also provide the position at which we want to pass, and then we can put in this position. For add, simply add at the end of the list. Add all, that's the bulk operation. It means that we can add multiple elements to the list. And remove, we need to remove the corresponding element. The search operation, we can check if the element exists. Since again, if you know that we have, as I just said, we have multiple duplicate elements in the list, and that's why we may have again the element inside the collection, but inside the list, but there are multiple such elements. And if we just want to clarify if the element exists, we can just check index of, search at which position it is located. If we want to take care about index of, it just shows at which position the element is located. If there are multiple elements, and then we may use last index of. It means that we may have multiple elements, but we are interested only in the last position the element is located on. Right, then we have the iteration. Now we know how to use the iterator already. Which with list iterator, which adds previous and has previous method. So we use just simple iterator interface, but there's also list iterator interface, which allows us to also check the previous element. There's also check, check if this exists, or we want to navigate the previous one. There's also range view. That's the subList method performs for range operation on the list. We will maybe check it a little bit later. Let's see. Then most of these implementations for the lists are array list. We already used it so many different times. Linked list, as I described already today, and vector, also to wait how the lists can be used. It's also quite the same. It looks quite the same as array list, but for the vector, it's, as mentioned, thread safe. It means that if we use multi-threading, it will not be available from other threads. That's why it's called thread safe. Then let's go to set. Set is also another type of collection in Java, and that's a collection that cannot contain duplicate elements. It contains only methods from collection, and there are also some restrictions that, again, as mentioned here, we do not allow duplicate elements here. Yeah, most we use hash set, linked hash set, tree set. Yeah, for hash set, there's equals and hash code work a little bit differently, but a little bit tricky way. But yeah, this is a little bit different question. But yeah, basically mostly we use tree set or hash set. The structure for them is different. Basically the storage and also the accessing is different. For tree set, the idea of tree set, as I described in the first course, but you can also describe it here. We have the trees. Programming maybe better just like in Java. Okay, there's no bigger picture. Okay, never mind. Yeah, we have the tree. That's what's called tree set, and the idea is that tree set should be sorted. Not should be, but it will always be sorted. It should be sortable. Like you have the elements which can be sorted. It means that they should be compared, right? Because the only way how you can sort any types of elements is that these elements should be comparable in some way. Like anything, if you want to sort anything, then you need to compare. You should be able to compare each two elements. Again, if that's the numbers, and if that's the strings. It can also be the persons, but in this case, you just need to define how to calculate which person should be, let's say, greater than another person. How we can determine it? How can we calculate it? And that's what needed for tree set, and the structure is that they are defined in the trees, using the trees, and this is the way how we can store the sorted elements and actually put and read sorted elements. Yeah, this can be based on the tree structures. The key point: what kind of collection to use? If it's set or list, and if it's array list, linked list, or it's hash set or tree set. It depends on multiple things. First thing again is if the data can be sorted or not. If the data cannot be sorted, then we are not allowed to use tree set, but we can use hash set. Hash set, since we work with the objects, and if the objects are not comparable, then it will, again, as you can see here, it does not allow duplicate elements. But what it will check the references. So in this case, basically it just checks the reference of the object and does not allow the same object to be added twice. For the tree sets, we have the again, all the elements should be comparable, and it just means that you cannot add, of course, you won't be able to add the same objects with the same, because they have the same reference, of course, and it means that they all have the same data. So that's pretty much obvious that you cannot add, but you can also not add the elements that again, they should all be comparable. And it means that they have the method equals all the ones, and if method equals returns the the fact that the elements are the same, I mean that equal to true, then you will not be able to add the element to the collection again. So then all the elements should be sorted and no duplicate entries are allowed. So how can we handle the elements in the collection? In collections, all collections allowed to contain objects. That makes sense. Therefore, any object can be stored in collection, except primitive types. So that's one important thing that because basically the thing is that collections use generics, and as you know that we can only use the reference types to work with generics. That's why for the collections it's also not possible to use primitive types. So therefore any objects can be stored in collection. To store primitive types, as I said, let's use wrapper class, integer instead of integer, character instead of char, and so on. Double instead of double, which starts with the lowercase and so on. And casting could be necessary to get the element from the collection. Like if we don't use generics, why I usually use generics? Because if we don't use generics, like in this case, then by default the type of the elements in linked list would be the object. But since we want to use, let's say, this object as the file, then it means that we need to do the downcasting. Downcasting. It means that we go from more general object, which is more general type, which is object, to more detailed type, which is file in this case, and that's why we provide such information to Java that the type is file. The type can be casted to file, and only after that we can put it to file. Also, in such cases, it's also not safe, because the type, because let's say that here we don't have any checks for type we pass here. In fact, here we can pass not only file, but let's say the string as well. It's not prohibited here, because we don't define what type should be here. And then we cast string to file, and as a result we will have cast exception, because we cannot convert string to file. And in this case, this structure is not safe. We better use generics, and using the generics we actually will not allow any other type but file to be added to the collection, because we actually provide it here, Sorry. So the type will be defined at the beginning, and everything will be fine after that. Everything is checked, and in this case we do not provide. We do not do the casting because the program already knows that the type is file. Then bulk operations. For example, if we want to merge the collections, that means that we need to pass the content of one collection to another collection. Why not? It's possible, and in this case, we need to use such methods like add all to add one collection to another collection. Contains all, it just checks if the collection we are targeting to does have all the elements from the collection we are passing to this method. Remove all, basically same as add all. Remove all removes all the elements in the target collection. If something is missed, then it won't be removed. And there may be, for example, some exceptions if you are processing, not exceptions, but I mean the exceptions not from the programming point of view, but from the real life. That let's say you're processing some data, and then you want to exclude something from this data, then some exact values. Then you can just remove all, and then this will remove all the elements you want to remove from the data. Retain all means remove from the target collection all its elements that are not also contained in the specified collection. So it basically works as remove all, but not only the elements that are passed, but the opposite element which exist in this collection, but do not exist in the collection we pass. And query just removes all the elements from the collection. So this is the table of interfaces and implementations. You can check it out and see which interface is implemented in which class. So basically, again, as I said, there's a possibility that multiple classes implement one interface, like the set, and also it's possible that one that's quite interesting. Because linked list also, if you remember, linked list also should be the part of query as well. It's not mentioned here for some reason, but okay, it's not so important. Basically, here you can check the table in overall. Alright, let's have 10 minutes break and then we will continue. Okay, let's continue. And yeah. So basically, you can see the table. Here you can see some code examples. How basically can we use the collection, different type of collections, and we'll have different results for them. So first of all, if you use sets, then expect that. So what? Maybe let's just go one by one. So one example by one. Maybe we have just two examples. Okay. Yeah. So let's say that we use the set. We should have all the unique elements. But since this is a hash set, it means that the sequence for there's actually no way we can determine the sequence for them. For the hash elements. Actually, there is the way, but that's not. It's based on the hash codes, and it is not obvious for us. Not for us, but we basically for hash structures we never use the sequence, the order of the elements. We just assume that the elements are stored. They can be stored in a chaotic way, and the sequence, the order depends on the hash values, which based on some hash calculations. That's why we can't do it this way, but what we can do, we can just add the elements and check if the element exists, and also remove the elements from the collection. So basically, here's what you can see here. We add the element, we first add one, then we add second, third, but at the end we see that the first one is 1 second and not third, but 5.0. Yeah, that's and also double kill is not added. Then we just have second, and that means that we cannot add the same element again. But when we have list and we just have the same operation here, then the order will be the same as when we add to the list. We have 1 second, third, 4, 5 second, and everything will be accepted here. So that's the difference, and the order the same as we provided the elements here. Right? Then the iterators, our favorite thing. We already have so many stories with them. The iterators come from the collections, and mostly are used for the collections to just basically go through the elements of the collection. So what does it mean? It means that we have the tool which allows us to do it, and we usually use such methods like next and has next. We use has next to check if there's the next element we want to iterate, want to go to, and we use the method next to actually get this next element. And if there's no next element, then the next element will be good. Also for the lists, there's such thing like list iterator. We haven't used before, but we'll check it. A little bit later. List iterator, which is basically also the iterator, but in addition to the simple iterator class, not class but interface, it also has the methods previous and has previous, which basically does the same as next and has next, but on the opposite direction. So this is how it looks like. You all know. Use iterator, we get iterator, and then we just implement it, and then just go through all the elements there. This is how the hierarchy looks like. Yeah, we can use iterate, but in addition, sometimes for the lists, again, we can use list iterate, and yeah, there's also add and set element, also if needed for them, for the operation. So it means that list iterator is is more advanced than just simple iterate. So we have more elements here, more options to do, more methods here. Then we have queue, and queue, the idea of queue is first in, first out collection for holding elements prior to processing. Besides basic collection operations, queues provide additional insertion, remove, and inspection operations in the following way. So basically, if something is wrong, then add throws exception, but offer return special value. Same as for remove, pull, element, and peek. And that's basically how what are the methods used for queues. Then there's also dequeue. Dequeue, that's the linear collection that supports element insertions and removal at both ends. So basically you can just get the element from the top and from the bottom as well. So for example, I can use the methods add first, offer first, add last, or offer last. This will throw the exception, and this will return the special value. And the same is for remove and examine. You can just want to check if the element actually is located at the first or the last position, then you can call these elements or these methods. And it's used first in, last out collection. That, for example, for stack, actually we can call first in, last out. The same way would be that we call it last in, first out. That would be the same. So that's about this type, and there are some coding devices. Usually what we do, we usually don't use the definition of the wall clause, because we usually don't need it. For example, for lists, we do not define the variables like linked list or array list. We define the variables as the interfaces. And why we do it? Because in this case it provides us, because actually we have all the all the methods defined in the using list interface, so we actually don't need more. And in addition, it allows us more flexible work with this variable, because sometimes there are the methods which accept list, in this case there's no need to actually work with something more special. And also, if we want to create new methods which process the lists, and again, let's say that this definition comes from the method which processes the list. Of course, in this case, it's better than just define the list and on special type, because there's actually no need. It makes more flexible usage for this variable. For second variable, it's also a slightly different implementation. Like if you just define the variable, then you can accept multiple. You can just reuse the same variable with different collections, with different collection types, list types in this case. Then the reference comparison. Please remember that for the objects we use double comparison mark if we just want to compare if the objects if they're the same objects, they have the same reference, the same address in the memory. In such case, we use equal, we use double equal sign. Yeah. But if we want to compare the content of the object, then we use equals method. Both of them return true or false, but the idea for them is different. Yeah. So similarly, not equals to it also returns true if both references are not known but refer to different object. Yeah. So that's basically the idea. Yeah, also hash code. There's the implementation for hash code, and basically the hash code generates the unique value of the object. Like in this case, that would be that you have the class myDate. For example, you have day, month, and year, and then you have the method equals, which allows you to compare the current object of myDate with another object. In this case, it accepts everything, but usually you can compare only with myDate, and what we do, we can just compare all the elements and return true or false. In addition, what we can do, we can generate, basically we can do the hashing. And when we talk about hash code, it's really that would be really nice to talk about the hashing itself. Basically, what is hashing in programming? In programming, hashing is it's not, I would say, the games, but what young people just to entertain themselves do, just to randomly do some things, let's say this way. And hashing basically also can be explained in the way that you randomly calculate something. Basically, this is what from the stands from the name hash. Just hash all things down. Basically, it means that you have the values, and you need to hash them. So you need to and what basically it means? It means that based on the values provided, this will return you another value which in some way it will represent the value what you want to hash. The ideas may be different. For example, in this case, we want to calculate something like unique value based on the elements provided here. So it means that, to be honest, I'm not really sure if this may return unique value. I think no, it will not return the unique hash code. It will not. Hash code should always be integer. Yeah, that's always. But what in such case there may be different meanings and different targets of hash values. In this case, we should, again, as I said, we should represent the object using integer value. And what we try to do, we try to make it the value as unique as possible. So it means that based on the day, month, and year, we want to provide the unique, not unique, but as much unique as we can, the value, which is hash code, and which will uniquely represent this date. And yeah, as you can see, something is calculated here. We have date as month times 32 times plus year times 40. In fact, this will not be unique value. because let's say that we have the let's say the first year and the first month and the first day. So the value would be maybe let me know. Maybe let's just use notepad. So we have this function. So it means that the hash value hash code equals day, month, and here. So let's say that we have the date 01, 01, and let it be 01. Okay. Why not? Then the hash code is hash code would be 1 plus 32 plus 400 equals 133. So this is the hash code. 433 is the hash code for the 1st of January of, let's see, the first year. In addition, what yeah, in fact, okay, maybe this is, yeah, for this case the value will be unique because this is the smallest value. There is no combination. We can get the value which is, but actually we can have the 0 year, but okay, let's just start with. Well, let's have another example. Let it be let me think. Let it be the year. Okay, maybe let's just find the current date. So that's the date, current date, and the hash code is 7 plus 7 plus 4 times 32. That's 130. Sorry, no, it's 128. It's 138, and that would be that's 800. So that would be 84, and so the result. Let's just quickly calculate that. Would be faster. So we have 7. That's 7 plus 100. Sorry, 4 times 32. Plus 2021 times 400. So this is the hash value we have, and let me think. Can we reproduce the same combination which will get as this value? That's a really interesting thing. So that's the hash value for the current date. Let's let's assume that let's check if we can reproduce the same value. Let me quickly check. If we use the year 2020, then multiply it by 400. Okay, then for year 20, the multiplication by 400 would be 808,000. So it means that we must get 535. 535 to get the same hash value. So, one moment. Yeah. So let's say that we multiply 32 by 12. Okay, and then that's not possible to achieve. I think that's maybe that this hash value may be unique. I cannot prove it right now, but it seems so. Yeah, it's quite interesting. A moment. Hash code. So we quickly check in Google. So that will be hash code for date. Yeah, there is. Say unique hash code. It's quite interesting thing if we can. There's the method in Java, but is it really unique or is it really unique or not? Okay, I'm not sure, but this seems to be that this may produce the unique value for the date. Moment, let's maybe use some small dates. Let's say that. No, actually we want to achieve. We will not be able, and for the date, the proof maybe for the date the proof maybe that that month multiplied by 32 cannot be covered by the days. Because it will always be greater than the number of days. And regarding the year, it's too large to compensate the month. So in this case again, I'm not 100% sure, but it seems that this value is unique. So that's for hashing. That's a really nice feature that we have the right value. So it means that the object can be represented with the integer. That's the same as we have the string method. It represents the object as string. Also using the hash value, we can represent the object using string, but using integer. But for the objects, for the hash values, it's not mandatory that it is unique, because in some cases it's possible that the hash code is not unique for the object, and sometimes this may be a serious problem. But again, it depends. For example, some hash functions, like in this case, this is hash function. So we have the hash function based on 3 arguments. So basically, we provide day, month, year, and we get integer. So this is hash function, and this is what the hash function is called. We just hash the values provided. So this hash function is quite nice because it seems that it may provide unique values, but some hash functions provide the unique values with some probability, theoretical probability. So what does it mean? It means that there is the probability. There is probability. We are sure that that the hash code will be unique for the value provided. So there may be such case, but in other cases the probability may be high or it may be low. It depends on the hash function and the hash and basically what we provide to it. But sometimes, like in this case, okay, maybe the calculation is not quite complicated for the date, but to hash, let's say if you have the large data with the names, for example, you can have the titles, the names, and you want to hash hash all these things, then of course there may be some, they call collisions. It means that some duplicate hash codes can be provided, but it also depends on the hash function. If the hash function is quite good, that the probability probability to have the duplicated hash codes is quite low. But it also depends on the resources, because again, hashing depends on the calculation. Like in this case, we have the calculation. Okay, multiply by 32, multiply by 100. This is not quite complicated operation for Java, for programming, I mean, mostly. But in some cases, hash functions can be more complicated with, let's say, some sine, cosines, let's maybe or something like that as well. So in such cases, square roots. Yeah. In such cases, it may take more resources for the program to calculate the hash value, and maybe in some cases it's maybe better to accept relatively higher probability of getting the duplicated hash codes than to write the complicated function, which will slow down our program. And this also may be in place. Alright. And yeah, also one more thing about the hashing, maybe that I had such experience in my career that using the hashing, we need to, basically what I had to do is there is the list of the elements, and the elements were the numbers, and also not only the numbers but also the strings. Basically, there are the codes, which is basically the product codes, and based on these product codes, I had to hash them in 100 different buckets. Actually, there was the explanation of this task. Maybe I will not explain it right now, prehistory of this task. But yeah, the idea was to create the hash function, which based on the value provided, it returns the number of the bucket to which the corresponding element to be placed. And the idea was to put the elements into the into 100 buckets, and the idea is that I had the data of as I remember 200,000 elements, and I had to split them into 100 buckets, and the task was to make it in the way that we will have pretty much the same number of elements in each bucket. Yeah, so it means that we have 100 buckets, and it means that in each bucket there should be like about 2,000 elements. And also I used statistics, some statistical approaches to test if the actual distribution is uniform. Yeah? Means that it should make the uniform distribution at the end. Okay, so then we have sorting, and it means that collections can be sorted. by default, three sets should always be sorted based on their structure, but also, if needed, we can also sort the collection. So when we have sort method, it just sorts in natural way. Like if you have integers, just sorts from smallest to largest. For strings as well, strings can be compared from the alphabetical way. Collections of custom objects can implement custom sorting by implement comparable or compared to interfaces. That's what we do for our custom objects. Means that let's say we implement comparable interface, and this will have the method compare2, and based on compare2 we can compare two objects. Then if compare2 returns negative value, it means that the object we are checking is less than the object provided. If the value is positive, then it returns it means that the object we are checking is greater than b, and if it's 0, then it means that two objects are equal to each other. This is what we have. Means that a equals should be true. Hash code should be the same. That's for sure. We may have the same hash codes for the different objects. Sometimes it's possible, but it's not possible for the same. Like if we compare two elements that they have different hash codes. That's not how it should be. And we can also check compare2. That should be 0. And if objects implement comparable or comparator interfaces, then they can be grouped in sorted or sorted not collections. Sorted set or sorted not collections. For example, tree set. Inside tree set, we can put only the elements which are sortable or comparable. Consistency of ordering inequality. So for proper object sorting or comparison, we should check that if equals true, then compare to and compare return 0. The hash code is the same. As I said, and it is not required that compare to and compare returns the same results. But it's not required. But if they return 0, it means that the objects are the same. So using compare2, we represent so-called natural ordering of the object, and then we can create several implementation of compare2, use different sorting. But that's maybe a little bit tricky case. Usually we just use compare2 and implement natural ordering. Basically, the summary of all the collections. So this is collections itself. That's the collection itself. That's the interface we use in Java. That's the main interface for all the collection types. Then we have distinct interface trees like set, list, queue, and map. So these are the main types we use. So the idea for set is it does not allow duplicate elements. A sorted set makes the collection to be sorted. Like if we provide 1, 3, 2, 5, and 0, then the order will be 0, 1, 2, 3, and 5. And so it should be sorted. List is just a simple way of storing the elements, like we have the arrays, just the list of the elements in the ordered way. Like we pass the elements 1, 2, 3, 4, 5, and they will be stored in the like 1, 2, 3, 4, 5. It's exact order we put them into the collection. Yeah. So when you just want to control it yourself, then you can use list. And QA represents maybe more advanced type of controlling the elements. For example, insertions, extractions, and inspections. Operations typically use first in, first out. Then from DQA interface enables insertion, deletion, and inspection operations, and at both the ends. You can use for your starting elements and also for the elements at the end of the collection. And yeah, we have map interface, which maps key and values, similar to hash table. And for sorted map, the idea is that, like, if you use tree map, then it means that all the keys should be sorted in ascending order, or in the order specified by comparator, which can be a little bit different, but it depends on. Okay, yeah, this is what we have from the theory point of view. I think for today that's it. If you have any questions, you can always reach me. So yeah, then we have the session on Friday. So have a nice evening and meet you all on Friday then. Bye.